everyone. Thanks for joining us today. We've got a special webinar this time. In before times, we would have been in Brisbane, sunny Brisbane, at the ITS Australia AP Forum. Unfortunately, that hasn't been able to happen, but we've got a panel that was going to be presented in Brisbane on 5G and related issues. So we've got wonderful people that are dialing in from around the world at awful time zones for them, and I'm going to let them introduce themselves. Just go through to the members slide, Jamie, and I'll just briefly touch on ITS Australia, obviously. Thanks for joining us for these webinars. It's been really interesting and useful, and understanding who's wanting to find out more about what we do. A lot of these people traditionally come to our events, but a lot don't, so it's great to see these new faces. If you see your logo on this slide, then you're a member, so get in touch, and if you don't, as I always say, get in touch anyway. Really happy to talk to people right now in particular. So we've only got 45 minutes. I've got a lot to cover, but we really want your questions. So the guys are going to run through relatively short presentations from each of their perspectives and their organizational perspective, and then we want to take questions and test what they've said and have a chat. So send the questions through as they come to you, and then Jamie and I will field them with our panelists. So Jamie, I'm going to hand over to you.
Thank you, Stacey. Hi everyone. So you've seen the preamble in the invite as to what this event is about, and we've given you a brief bio of the speakers. So we're not going to go into a lot of detail about each of the speakers, who they are, but focus on what they've got to say. So I'm going to be moderating, and my job's pretty easy. I'm just going to hand over to Jason from Qualcomm first, and he's going to hand over to the rest, and I'll come back at the end and pick up some questions which we'll pitch to the panelists. So the first thing I want to position, what we're talking about is the cellular V2X technology and everything associated with that. We're not going to dive down into the underlying technical engineering of how it works. We're going to focus more on the use cases and the opportunities to accelerate the deployment of cooperative ITS around the world. We're certainly going to explore different dimensions from different perspectives, which you'll see as we go through the slides. The members on the panel are all members of the 5G AA, and the 5G AA is a global forum made up of a large number of motor vehicle manufacturers and mobile network operators and their associated technology partners. And the purpose of the forum is to accelerate the adoption of cooperative ITS through cellular V2X technology and influence all of the stakeholders that are associated with this. I'm going to hand over to Jason Ellis from Qualcomm, and Jason will run through a couple of quick slides, and then we'll move on from there.
Okay, so thank you. First off, if you've been affected by the virus, clearly we're thinking of you, and we hope that that we get through this and can do this in person in the future. But we're very appreciative to this forum for letting us have this speakership. So cellular V2X, as was mentioned, is two components. One of them is the short-range communications, the other one is the long-range communications. And we came up with this technology as an industry, really evolving cellular technology from where it was and building upon a lot of really good work that had been done over the last couple of decades in ITS. What I was asked to present is the fact that this is now commercial. This is a commercial reality. There's products, there's solutions, and there's even vehicles and infrastructure that's coming. Qualcomm has introduced a couple of years ago our first product. It was a C-V2X direct communication solution by itself. It's in production for a couple of years now. We've also done something which we believe will really help usher in the technology, and that is what we call the Snapdragon 4G and 5G chipsets, where we integrate both the network communications and the direct communications into the same chipset platform. And that's important because cellular communications has already really had a strong role in automotive connectivity dating back 20 years. And the use cases are really starting to get super exciting. And even though I'm not speaking about the use cases, we can imagine all the many different types of scenarios that are going to come together from connected cars and connectivity on the roadways. So we've introduced these 3 chipsets. All of them have direct communications and the more recent direct communications and network communications. And then these chipsets, combined actually with some additional processing, have been developed and are now commercially available by a number of global suppliers. We call these in the telecom space mobile module suppliers. These suppliers in turn enable, if we can go to the next slide, they enable the product companies. So roadside units, onboard units, these are products today that are shipping. So if you're looking to add C-V2X to your vehicles, to your fleets, as well as to your roadways, whether to do full commercial, to do some early deployments, or even just to get some practical hands-on experience with it, many recognizable names. In fact, a number of them are members of this forum as well. You can get the roadside units and onboard units directly from them, and their websites certainly will link you there, but you can Google it as well. In Europe, we've gone through some extensive testing. We're continuing to do testing around the world, but we've also got the certifications, so we can actually sell the solutions now at the product level. There were supposed to be a few more product announcements recently. Naturally, because of where we are today in the world, some things have been delayed. They're still going to be announced. And some of the customers have already got products in hand. But needless to say, this is the beginning of many, many more products that we already know are coming. The other thing is, automakers historically, for telematics, which is connected car, and for many other technologies, don't typically like to debut what technologies they're incorporating into their vehicles. So there are a number of automakers around the world that are busy integrating technology today. There are a few public announcements from some of the companies, but in general, we're pretty excited about what's happening on the automaker side, and it's different in region to region. But that's okay. And then finally, there's some creative products that have been developed, in particular in the United States, where there's still some discussion about which short-range communication technology may ultimately fit the bill. There is this notion of a dual radio roadside unit, which has DSRC and C-V2X in it. It's a practical way of moving forward with public funds if you're not quite sure which direction things will end up. And then there's also some companies that are working on roadside units integrated with traditional cellular infrastructure, which is also quite interesting. But that's what I have to say. I really wanted to show you that there are commercial products, and certainly you can follow up afterward if you have specific questions on that. Thank you.
Yeah, thank you. So now I would like to give you a little bit of different perspectives around the technology. Next slide, please. Especially, I would like to focus a bit more on the cellular leg of the C-V2X technology, which, as we know, is built on this complementarity between short-range communication using PC5 and the cellular connectivity through network operators. So if we maybe we can, yeah. So if we look at connectivity for a modern vehicle, we see a lot of many different use cases. CITS is what we are mostly talking about here. It's about basically regulated services for traffic safety and efficiency, mostly about informational safety. And that, as we know, is delivered by the combination of PC5 for short-range communication and cellular connectivity. There are, however, pretty similar services in terms of, let's say, intent of delivering improved road safety and efficiency related to ADAS, which today is mostly based on sensors, but that is being complemented with communication. And differently from CITS, that is mostly triggered by a fully private type of ecosystem. And what we noticed when we analyzed this in Ericsson is that all of these very many different use cases are very different in terms of stakeholders, business cases, and communication requirements, but they have a couple of things in common. The first one is that all of them can be enabled by cellular networks. And not only that, basically the greatest majority of them can already be implemented with a good, well-designed 4G network. Especially if we focus on CITS and ADAS, then in terms of network performance, the really critical aspect is coverage. That's the most important part. So it's really important to rely on a cellular network that delivers this type of geographical coverage, and then 4G really plays an important role in that. If we go to the next slide, I would like to give you a slightly different perspective here regarding what can 5G add to what we can already build using 4G. And for this, I will give you an example based on reality. So this is a demo we did in 5GA last November in Italy, and we used actually a commercial 5G network, one of the first ones in Italy. And in that case, we had two vehicles. The first one was using cyber tires connected to the 5G network, delivering information real time and experiencing a situation of aquaplaning, which, by the way, I heard is quite a common problem even in Australia. And that information was delivered to a local edge cloud, which processed the information and delivered in real time to approaching vehicles who are interested in that information. This rich information that can be delivered using 5G was used to deliver the service using augmented reality on the infotainment display. We also had other use cases in the same demo, which included technologies such as eye tracking and so on. All of them and connected also smartphones, for example, for pedestrian safety. All of these using 5G network. But what I really want to emphasize is the fact that there is a natural evolution from 4G to 5G here. So these services can already be delivered in more maybe basic form using 4G and complementing it with short-range communication, especially when especially for V2V type of use cases when the vehicles are relatively close to each other. But then this information is definitely useful also for vehicles that are more further apart, or information that benefits from a central intelligence, maybe machine learning that benefits from information collected from a bigger fleet. And that's the case where cellular really makes a difference. So my point is, thanks to the additional richness of the information processing that can be delivered using cellular, these use cases not only deliver additional safety, but they also deliver a richer experience to the driver, which hopefully will also accelerate the adoption of these use cases and also the level of safety that they can deliver to society. And next slide, please. I just wanted to provide a slightly different perspective. Finally, of course, we are focusing on automotive, but there are different industries that are also dealing with really critical services. And the interesting trend that we see is that they're moving from dedicated networks towards partnering with network operators and using combinations of 4G initially and in the future 5G to deliver very important critical services. One example is FirstNet in the US, which is using AT&T's commercial cellular network. It's exactly the same infrastructure, but thanks to existing cellular features, they prioritize the traffic for first responders, for example, so that they really obtain this additional level of service and requirement, which is of course very important for first responders. And something similar is happening also in the railway world, where at least in some countries, railway companies are moving from ad hoc dedicated technology towards partnering with operators or delivering cellular networks, private networks for this type of use cases. Thank you.
Thank you, Stefano, for the overview. So my name's David. I'm from Telstra. We're more on the, I guess, consumption side of this rather than the technology creation. But one thing I thought I might talk about first was a little bit of a view of why, from Telstra, we think that the mobile connectivity is going to be so important here. And there's a couple of charts on the screen there. The first one just illustrates the number of kilometers of road per population. And it's an interesting data point. It puts us in sort of a very similar company with Canada, for instance. But in fact, if you look at that across the world, we have in Australia a tremendous network of roads given the population. And a lot of that is because of our extensive rural and regional highways. But what's important to remember is that regional and rural highways and other types of roads in Australia are overrepresented in terms of crashes and major incidents on our roads. So these are actually areas that we do need to concentrate on technology solutions. Telstra has been building 4G for nearly 10 years. We went from launch of about 30 regional cities to 99% of the population with 4G coverage now. And that includes most of that road network. So it's a big job to build networks with this kind of coverage, and being able to leverage that for other applications, as Stefano alluded to, is a really important way to accelerate uptake. We've also launched 5G, so it says 30 plus cities. Actually, as of yesterday, I think we're at 47 cities now, so nearly at 50. And we're building 5G as quickly as we can. So where that coverage exists, of course, you get greater depth of experience. But I think the point Stefano made was really important, that we can start on 4G and move through to 5G. Next slide, Jamie. What's also really interesting in this space is that, in fact, C-V2X is not new. We've just called it telematics for a long time. So vehicles have been connected to networks for many years, and this of course will continue into the future. And so what I want to paint here is a little bit of an ecosystem picture of how C-V2X fits into those existing services, which will continue and enhance. So what you can see there are a couple of vehicles that connect to, as they do today, a range of different cloud services, whether those are safety services provided by a particular manufacturer, or mapping, infotainment, those sorts of services. And this is already happening across the world, making different use cases come to life. If you go to the next slide, Jamie, the first thing that we see, of course, is, and there's been a lot of work done on this, bringing in a complementary radio technology like, it's called LTE V2X in this slide, also known as the PC5 interface. And this is for safety critical short range services. So Stefano mentioned when we have two vehicles that need to communicate to each other, or as shown there, where you have a roadside unit available and that's itself connected to a road authority. That's what a lot of the discussion has been about. And that's a really important part of delivering safety critical services. But if you go to the next slide, Jamie, what we also envisage is that we will route cooperative services, safety critical services and time sensitive services across the mobile network as well. And that will work in tandem with those short range services, but quite distinct from the telematics, the infotainment services over on the left. And so what we get is the ability to move between short range communications between vehicles over PC5, or short range communications to infrastructure where that's available. But for all of the road network where that's not available or will take some time, There's a rich set of use cases that cellular V2X can deliver over the public mobile network. And so that's the future and the ecosystem that we think makes not just good safety sense, but good kind of commercial sense. And that's really important to ensure that we have a time to market story here as well. Go to the next slide, Jamie. And so we've done a lot of work on getting 4G ready for V2X. We have demonstrated that we can achieve extremely good latencies across the network. And so that's the time it takes a message to enter the network, be routed through the network and back to another vehicle, V to N to V, down at on the order of 50 milliseconds reliably, or from some infrastructure to a vehicle with a one-way trip. It can obviously be nearly half that. And this, as Stefano mentioned, uses a lot of the technology that's already in place on our network. The same sorts of prioritization that's used for other industries, but now being applied to V2X instead. It certainly doesn't replace any of the short-range communications. That's still the primary source for vehicles that are close to each other. But what it does do is gives an easy pathway to extend situational awareness for vehicles over much wider areas, down lengths of highway, lengths of freeway, around corners where there are obstructions, without requiring mass roadside unit rollout in places where it's simply uneconomic to do so. And CV2X is the technology with these two interfaces, these two different communications modes that lets this happen. So that's all I had to say, Jamie.
Okay, thanks, David, and thanks for the opportunity to share Ford's perspective on CV2X. So my name's Craig. I'm based at the Ford Engineering Centre in Melbourne. And I just wanted to kick it off quickly with just sharing a couple of points around Ford's operations in Australia, I guess given the audience we have online today. So Ford is actually Australia's largest direct automotive employer, and we're a key development hub for Ford globally. So we have actually 2,000 people here in Australia, and we invest an average of $500 million each year in Australian R&D. And we're really proud to lead the engineering of the global Ranger and Everest vehicle lines as well. Next slide, thanks. So Bill Ford, who's our executive chairman and Henry Ford's great-grandson, has often said that the mobility solution we have today simply will not work tomorrow. He's a really strong advocate for finding the range of transportation solutions that need to address the increasing urbanisation challenges we face. So to address these challenges globally, we are working with partners to accelerate CV2X technology worldwide, and we really feel that provides a really important role in improving automotive safety and traffic efficiency. Okay, next slide, please. So looking a little bit more at the vehicle side for a moment, today the vehicles, including Ford's, have camera and radar capability to offer driver assistance and safety functionality and features. But in addition to this, there is 4G connectivity on the vehicles. So by the end of this year, 90% of all new Ford vehicles around the world will have 4G connectivity as standard. And that's a really great step towards the ultimate goal of 100% connectivity for the whole Ford fleet. So the CV2X technology really builds on that in a couple of key ways, as some others have mentioned. So obviously first being a cooperative technology, and really secondly bringing, I guess, some of this feature capability around non-line of sight awareness, where you can address things like blind intersections and bad weather conditions as well. So given we said that 4G connectivity is becoming standard on the vehicles, it really, and what Jason showed in his slides as well, the chipsets include the capability of 4G and the PC5 short-range technology as well. So we really just add the PC5 antenna systems to give that 360-degree vision around the vehicle. Next slide, thanks. So I just wanted to touch on maybe a couple of these points of kind of key points of our perspective from an automaker. The first being implementation efficiency. So I mentioned how vehicles become increasingly connected. So with that combination of PC5 and UU and the chipsets, it really gives us a good standing for an integrated architecture for the cellular platforms that are being deployed. And that can have some benefits, particularly in improved quality and possibly lower feature costs coming to the consumer as well. And maybe I'll jump to the evolution one. So I guess vehicles do have a typically longer lifespan than most consumer products. So future evolution and backward compatibility are very important. So 5G will bring obviously new opportunities, new use cases, but we still have the opportunity and the necessity to be able to communicate to older vehicles in the fleet as well. And maybe just finally there, so we've seen there's a complementary technology, so we both have PC5 and UU, but if when operating independently, PC5 really brings some kind of key performance and reliability advantages. And that's really important when you're considering some of these safety use cases that we're talking about. Okay, next slide. And just finishing up with some real world readiness news, I guess. So at the start of this presentation, Jamie shared, I guess, the list of members in the 5G AA, and we really feel that demonstrates the support of a broad ecosystem for this technology. And Ford has taken some significant steps in announcing our deployment. So all new Ford vehicles in North America will come with CV2X capability from 2022. And in China, who have also moved quickly on CV2X, will be offering some V2X features in vehicles from 2021. So thanks for that, and I'll pass back to Jamie.
Thanks, everyone. Really great, informative contributions. I guess the next session we've got for the remainder of the webinar is questions. Stacey's been collecting them, so where are we at with input from the audience, Stacey?
Yeah, we've got a range of questions, some quite specific and some more general. I'll just pass one of the specific ones across with regards to the Edge cloud solution that was deployed in the Italian pilot. If somebody could address that one.
Yes, sorry, can you repeat again just the first part? I couldn't hear.
What the Edge cloud solution was deployed.
Yeah, okay, yeah, thanks. Yeah, basically that was, so in that case we partnered with Telecom Italia, which is the local network operator. So it was a network delivered by Ericsson in that case, and also for the Edge cloud we basically partnered with the operator. It was not a commercial solution, it was a solution just for that trial. Let's say compared to a commercial solution, it lacked, let's say, the requirements of scalability. So that was intended to work for a few smartphones and a few cars. So that was basically, but I think what was really interesting about the project, we were something like 8 partners just cooperating in maybe 3-4 months to develop those really innovative use cases. And I think that's probably a bit of a message that we want to give, is like the technology is ready to deliver some use cases that, I mean, when journalists saw them, they started to write about them in all newspapers because it really felt like this is the future. But that was used with a commercial network.
Thanks. And there's one for you, Jason. On one of the slides you showed aftermarket applications. Is this considered a realistic market, or is it generally just for development and RD?
Those products are commercially available, and you know, some people may choose to play with them, but there's fleets that are using them, whether for particular services or, you know, there's certainly a lot of interest in not waiting until every manufacturer has embedded it in new vehicles and the amount of time it's going to take for those vehicles to proliferate. So there is also an aftermarket segment that we're excited about, and our customers who are engaged in those markets are busy evaluating how they're going to serve the needs. One of them would be how you do traffic signal information. You're approaching a traffic crossing, and you want to know what speed you might want to travel at in order to get consecutive green lights. Maybe you slow down a bit. So we have customers that are exploring how to leverage the combination of network communications and short range for those purposes. You may also have emergency vehicles going through traffic intersections, and they want to preempt the signal, change it to red, and maybe do so in a different way than how it has been done traditionally. So yes, very exciting opportunities. And then when you start looking at collision avoidance, then you start to contemplate how the insurance industry, which have certainly been engaged in the usage-based insurance telematics use case, how they might also benefit by having V2V communications for collision avoidance. So yeah, very practical market applications.
Thanks, Jason. That leads us to one for you, David or Jamie, on 5G latency. Is the 30 millisecond latency fast enough for evasive action in high-speed vehicles? And what's the expectation for 5G?
David, go for it. I just need to hold him back.
Start with that, and then even see if Craig's got an opinion on that, I guess, from the automaker. But I mean, our experience, and Telstra's been involved in a number of cooperative vehicle trials, is that we tend to be concerned about an end-to-end latency on the order of about 100 milliseconds for many of the introductory safety applications. And so as long as all of the components in that are within those sorts of timeframes, then you can have a really significant improvement to even something like a pre-crash alert. Our experience has also been that that time spent in the communications link is often one of the smallest contributors to the overall time spent. And there can be a lot of time spent, for instance, in vehicles processing all of these messages and making sense of what's going on. And so there are many different dimensions to latency. We're pretty confident that what we're able to deliver over the network at 30 milliseconds is suitable for many use cases. That is, of course, the network latency over the Telstra mobile network. It will always be in tandem with the short range V2V communications or V2I communications, which can go even faster. The other thing worth mentioning is, of course, we are rolling out 5G. The first version of 5G that we have has some latency improvements compared to the figures I put on screen, but we have also announced the launch of 5G standalone for certain applications. Now, that's going to take some time before that's widely available, so it's not worth getting excited about perhaps yet, but that does offer a pathway to extraordinarily low latencies across the public network. But maybe Craig, have you got any thoughts on what's an appropriate latency for safety use case?
Yeah, I don't necessarily have a time at this point, but I think to build on that, Ford sees both technologies as key parts to it. I guess there are, ultimately we look at it as a perspective of giving the feature to the customer in all environments and situations, and that's where the complementary nature comes in, given you have to work outside of the cellular network, and there's other obviously the ADAS systems in the vehicle to work in that as well. So yeah, we really see both aspects of the system working to support these things.
So on that safety use case, what's the business case for something with regards to road trauma that's traditionally borne by the public for deployment of these technologies on our infrastructure?
That's a really hard question to answer. I guess we know the road toll in Australia is around 1,200 people killed every year, predominantly due to human error behind the wheel. We know that 30,000 people get hospitalised, some whose lives are changed forever. We do put a number on that. Australia's sort of valued that the cost to the Australian economy of the road toll at up to $30 billion. And I guess it's not necessarily anyone's money that's paying for that, it's society as a whole. I think the message that we're signing up to here in this forum, and all of the 5GAA members, and indeed all of the ITS members around the world, is that if we can use technology to remove humans from that situation where they make an error through poor judgment, distraction, impairment, that's going to have a positive impact on all of those socioeconomic costs. So it's a difficult one to turn into a business case, because it's not really like, yeah, if I spend this money, I'll get this much back. It's more, if we do the right thing and accelerate the adoption of this technology, we'll stop killing people, bottom line.
Okay, yeah, it's a tough one. So on something more specifically technical, is there a backwards capability, compatibility between LTE V2X and NR V2X?
Yeah, so I'll take a little bit of the last question as well as this new one. So obviously we have Ford on the call, but in general, Qualcomm supplies wireless technologies and many other technologies to pretty much every automaker on the planet. And they all have the same goal, and that is reduce traffic incidents, make driving safer, not only for the drivers and for their occupants, but for the pedestrians and everyone else on the road. So with everything that's being done, and certainly the governments around the world are very encouraging of it, we're very happy that all of these automakers are doing everything they can. They may move at different speeds based on how they're prioritizing different technologies, but they all have the same goal: reduce fatalities, reduce injuries. So the next question, this is actually a really exciting question. It's the question basically is, has cellular V2X, and in particular the direct communications, has it anticipated evolution? And the answer is yes. Where 802.11p is the radio behind the SRC, it was a good radio for a number of years, but then it got old. So when we, as an industry, developed CV2X, we said, okay, we will also get old, so let's make sure that we're always staying current, and let's anticipate the future, and let's evolve with it. And so LTE V2X, which, even more technical, 3GPP release 14, that's the spec to which the industry globally has adopted. That begins the process of vehicle direct communications. But if we stop there, then where's the added capability as things progress and new use cases emerge and autonomous vehicles want new things? So there was planned from the very beginning a forward and backwards compatibility. So all vehicles would have release 14 as a base for the safety messages. As new technology comes, release 16 and beyond is what we call NR-V2X. That has added capability. So if I was to have 3 vehicles on the road, one of them with LTE V2X only, that was a vehicle maybe you're buying in 2022. And then I have the other 2 vehicles that are equipped with NR-V2X. Those other vehicles with NR-V2X also have LTE V2X built in. So all of the cars, all 3 of the cars are talking LTE V2X amongst each other and doing those safety use cases. And then the newer vehicles obviously have some additional capability to do more advanced use cases. That's just the nature of technology. It's been anticipated from the onset, and it keeps us, continuing to evolve as new technology and applications come online.
Yeah, you mentioned the new vehicles, and we anticipate that they're going to be amazing and really provide safety benefits and efficiency benefits. But we have an aging fleet, and a new report coming out from Ausroads on future vehicles just reinforces the relatively minimal take-up of these new vehicles. So what's the proposal, or what any plans with regards to retrofitting, or if there's a hybrid situation with lots of fleet being DSRC and the other being V2X,
Well,
consideration of that?
Yeah, so to the first point and back to the original question, there is a healthy opportunity for aftermarket. We see this happening in different regions for a number of different applications. Many of them come from the telematics space at the moment, but it's the same, in many cases, a lot of the telematics hardware suppliers for aftermarket that are also looking at how to serve V2X. When it comes to whether you're DSRC or CV2X, frankly speaking, there's really very few vehicles anywhere on the planet that are full commercial today available in either technology. Now, in China, things are very aggressive. Craig from Ford has also shown what Ford is doing. And there's a major European automaker, you know, they are going a different direction. I'll give them credit for that. But outside of that, there's not a whole lot of established vehicles today. So we're not talking about fleets of vehicles that would have one technology and not be able to communicate to another. I think in the next couple years, we should see this resolution. At the end of the day, the difference is not the use cases. We're all aligned on safety. It's a radio thing. And only a couple of companies in the world really focus on the radios. Everyone else is always pushing for, I want the best thing to keep my customers safe.
Maybe one thing to add to that as well. I think that when we look at it from an Australian perspective, I think a key thing, the first step is really moving to like a bit more of a technology neutrality for these different connectivity or V2X technologies. So I guess it opens it up for the manufacturers to really bring their chosen technology in and start those discussions and work through that. In regards to the aging fleet as well, I guess we see similar things. There's a lot of new technology coming into vehicles, so these are things and discussions that are ongoing. I guess we could also leverage off previous cases like autonomous vehicles. How do we manage that? So looking at all kind of the key stakeholders that have a part to play in this and working together on it.
We've got a few minutes left, so I might paraphrase some of the questions that have come through. There is a large chunk that are devoted to broadly security and privacy and managing those concerns. So if you could just cover off some of those issues from your individual perspectives, that would be great.
Yeah, I'm happy to take a start at that. I mean, it's very clear that security and privacy is critical to this. There's no doubt about that. What's probably also needed is something along the lines of a national framework for how security management is going to happen in Australia. So, I mean, that's a really critical piece that needs to be in place for any of these technologies to have uptake. And that's in many respects independent of this discussion about 4G, 5G, DSRC or otherwise, because all of these solutions can make use of the same underlying technology framework. With that said, this is not new. I mean, we have exactly the same situation occurring when it comes to, for instance, the use of mobile phones on the Telstra network today. With the right, I guess, information, it may be possible to identify or trace someone on the Telstra mobile network. But of course, we can't do that. We don't do that unless there's, you know, good lawful reasons to do so. We can build a technology around that makes sure that there's only access to those parties who really do need access for important reasons. And so, again, it's not new. We can take all of that learning from how we build a mobile network and apply that to the domain of connected vehicles. And that really goes to the notion of security and privacy. Of course, there's the other aspect as well, which is trust of the information that's being transmitted, and especially trust of that information when you're causing a vehicle to do something or automatically. That's a really important consideration. And that really goes to making sure that only the right parties can actually interact with any of these systems at all, whether that's the road authorities or a motor vehicle manufacturer, and have, again, that right security infrastructure in place to enable all of that. So there's a lot to it, but I guess the point I'd like to make is that a lot of this stuff is actually well solved in adjacent or similar industries, and we can bring that to bear on this problem too.
Okay, we're on time, so there's a whole bunch of questions that we haven't been able to get to. I think we've broadly addressed some of the key issues that have been raised, but I will ask if you can take some of these questions on notice, and ideally, if you can respond, we can get them back out and put them on the website along with the recording. And coincidentally, on the data, NTC are currently running a consultation on in-vehicle generated data. So we're having a webinar with them on the 2nd of July. And also a webinar tomorrow afternoon with Catch on GNSS GPS project they've been working on in Bulgaria. So thanks everyone for coming. Don't want to run over time too much. So really appreciate everyone coming along. If you've got any recommendations to the audience to get some more information, please do. And I encourage you to contact our panelists directly if you've got questions specific to them. So.
Thank you.
Thanks, Stacey. Thanks, everyone. Thanks for the opportunity.
Thanks, everyone. And obviously, yeah, we were meant to be in Brisbane at AP Forum. Go to our website and find out what's happening in 2021, because we've moved it to early next year. So look forward to actually seeing you all in real life in a vaguely normal world. So,
Stacey, before we go, sorry, just very quickly. You see the 5GAA icon on the screen there. If you're not a member of the 5GAA and you have interest in it, please reach out to any of the panelists. We're happy to connect you through to the right people, particularly for road operators who might have joined this call today. There's special membership status for road operators, which is at low or no cost. So it's a really good way to get access to this information firsthand. And especially while we're communicating virtually, I'd strongly encourage you to consider sort of getting right in the thick of this conversation, because there's an awful lot of good information you can get direct access to with that sort of membership. So I'd encourage you to go to the 5GAA website and or reach out to any of us to find out how you can join in a really direct way.
Thanks, David. It's great advice. We've got a lot of transport agencies on the line, so hopefully they'll take you up on that. Okay.
Thank you.
Stay well, everyone. See you later. Bye.
Thank you.